All right, welcome to Unit 1, Cycle 3 notes over is it a function? So, a very broad idea is what is called a relation. And all a relation is a set of data points. A lot of times we write them using ordered pairs. So, it's our x and y values, that's data. And we can represent x and y values in a lot of different ways. Some of the ways that we've seen so far are, we've seen it on a graph, right? We've seen them on a table. We've seen data in an equation, like y equals mx plus b. We've seen it in word problems, like in some of our warm-ups, perhaps. And then we've also seen it, but we will go into more detail in this video, mapping. And then finally, ordered pairs. So those are some ways that we can represent relations, right? So let's take a look at example 1. Let's tackle this. It says, represent the relation shown as a set of ordered pairs, a table, and mapping. So first of all, we've been given a graph, right? And now we need to represent this data in 3 different ways. So the first way is through ordered pairs. Ordered pairs are, in parentheses, and it's x comma y. So you put your x value comma your y value. So if we look at this graph, let's take this point first. Our x value for that point is 1. Our y value is 74. And then I'm going to cross it out just so I don't get confused. Then on this one, it would be 1 and 76. Cross that one out. And then I would go 2, 82. Cross that one out. I would go 3, 81. And so on and so forth. You go over for your x value and up for your y value. 9, 88, and then 10, 89. So those are all 8 of our points, all of our data written as a set of ordered pairs. Okay, so that's one way we can represent our data. Another way is through a table. This column would be x and this column would be y. Now we write all of our x values down in the x column and all of our y values in the y column. Whatever accompanies x, you write the y next to it. So our first x value is 1. So we would write 74 next to it. 176, 282, okay? So that is how we would write it in a table. Again, the same exact data, just written differently. Okay, finally, mapping. Some of you may have experienced this in junior high. Maybe some of your teachers called it double bubble or whatever you know it by. But this is how it works. You draw 2 ovals right next to each other. The first one is going to be your x and the second one is going to be your y. Now, when you write your values in, you're going to write all your x values and all your y values. But here's the catch. You don't repeat numbers. So since there are 2 1s here, I'm only going to write 1 time. I don't write both 1s. In mapping, you don't repeat numbers. So I would do 1, and then I would skip the other one, go 2, 3, 5, 7, 9, 10. Okay? And now for my y values, I also do not repeat. So I would write 74, 76, 82, 81, and then I have another 76, But I'm not going to write it because that would be repeating. 95, 88, 89. Okay? Now, the last step of mapping is to draw lines connecting the points. So 1 is associated with 74, so I would draw a line connected to 74. 1 is also connected with 76, so I draw a line to that as well. 2 to 82, 3 to 81, 5 to 76, 7 to 95, 9 to 88, and 10 to 89. Okay, pretty straightforward. Remember, on mapping, you do not write numbers more than once. You don't repeat. Okay? Now, domain and range. The domain is what is called the set of independent values. While the range, on the other hand, is the set of dependent values. Okay? And another way to say that is the range depends on the domain. The range depends on the domain. Right? Another way to remember this, if it's helpful for you, is on the x-axis, right? And I'll get to this in just a second. First of all, the domain is also the x values in a relation. So that would make range the y values in a relation, right? So a way to remember that domain is independent is if this is the x-axis and this is the y-axis, so this is domain, so it would be independent. You can make an I with your x-axis. This would be independent. Right? And then the y is your range, which is dependent. You can make a D with your y-axis. If that is useful for you, and that helps you remember it, go for it. But if that makes it more confusing, forget about it. Okay, that's one way you can help remember it. Now let's skip down to here. It says, when listing domain and range, you must make sure that there's three things we got to remember. First thing we got to remember is we have to remember to use curly brackets, or the more official word is braces. Looks like this. In your calculator, to get that, you do Control close parentheses. Another thing is you must write your numbers from least to greatest. Right? And then finally, no repeats. So all your numbers have to be written from least to greatest, meaning they're getting bigger, and you can't repeat any numbers. Okay? Kind of like how up here we couldn't repeat any numbers. So the domain of example 1, you would start out with your curly brackets because that's rule number 1. Rule number 2, it says from least to greatest. So our lowest number is 1. Lowest x value is 1. But it says we can't repeat. So we can't write number 1 again. We have to skip that one and write 2, 3, 5, 7, 9, 10. That is our domain for example 1. Our range, on the other hand, we start with curly brackets still. Right? And we write from least to greatest. So our smallest y value happens to be the one at the top, 74. 76 is our next highest. But we have another 76. We don't write that one. And then our next highest would be 81. Then 82. 88. 89. 95. Okay? So that is what we would get for our range. This is our domain, this is our range. Remember these three rules. Okay? So now, specifically getting into this, a type of relation, specific type, is called a function. So a function is a relation in which none of the x values repeat. Another way of phrasing that is all of the x values have only one y value. So let's take a look at example 1. It says, by definition, is example 1 a function? Why or why not? Well, if you look at the table, we have x values repeating. Number 1 is repeating. Up here, we have x values repeating. So, a relation in which none of the x values repeat, that's a function. So that's not a function. Example 1 is not a function because x values repeat. Okay? So that is example 1. Now flip it over. Example 2. It should say, is it a function? Notes. Example 2. So in the first example, we were given a graph initially. Now we are given a table. So on a horizontal table like this, the top column is the x, and the bottom column is the y. Okay? So if we were to write this as a set of ordered pairs, it would be x, comma, y. Right? So we've got them really nice and easy set up for us. This is an ordered pair, this is an ordered pair, so on and so forth, right? So our first ordered pair would be 1, 5, and then we would get 2, 6, because we got x, y, x, y, x, y, so it would be 4, 8, 5, 9, 6, 10, 10, 14. Okay? So that's how we would write a set of ordered pairs, x, y. For graph, we would do kind of the opposite of what we did last time. Last time we were given a graph. Now we're graphing ordered pairs. So we would graph our first point of 1, 5. This is our x value, so we use the x-axis. So we go over 1, and we go up 5. 2, 6. This is our x value, y value. So 2 is our x value, so we use the x-axis. We go over 2, up 6. 3, 7, same thing. Over 3, up 7. 4, 8 would be here. 5, 9 would be here. 6, 10 would be here. And 10, 14 would be way up here. Now, as a reminder, this is a discrete graph because it is a bunch of dots. A continuous graph, all these dots would be connected. It would be a line. But this is dots, so that is a discrete graph. As for mapping, you would...
Teachers and students, please pardon this interruption, but there's a black Infiniti license.
All right, as for mapping, your first step is to draw ovals, like we did last time. The left one is x, the right one is y. Now, we cannot repeat the numbers, but in this instant, x values don't repeat and y values don't repeat, so we just write them all. 1, 2, 3, 4, 5, 6, 10. Same thing. 5, 6, 7, 8, 9, 10, 14. And this one's pretty boring because 1 matches with 5, 2 matches with 6, all the way down. So each x value only has one y value. And if you remember, that sounds a lot like our definition of a function. So we'll get to that in a second. The domain, as a review, is all of the x values. The range is all of the y values. So our domain, given our three rules, our rule number 1 is we have to have curly brackets. Rule number 2 is it has to be from least to greatest. It's already from least to greatest, so we just write them, but make sure we have commas in between. Okay, now our range, it's already in order as well, and there's no repeats. So this one's pretty simple. So as a review, a function is when no x values, right, repeat. And would you look at that? We have a bunch of x values and none of them repeat. So example 2 is a function. No x values repeat. Right? That's our definition. No x values repeat. So example 2 is a function because none of the x values are repeating. Finally, so this is how you can tell from mapping and ordered pairs and knowing how no x values repeat. But another way is graphically. It is something called the vertical line test. The vertical line test is essentially this. At any point along the graph, you should be able to draw a vertical line and touch this line, this function, one time or less. Okay? So if you were to take a paper clip, make it straight, right? And I were to make a line go all the way across. At this point on the graph, right? This point on the graph, that vertical line is only touching my line one time. Right here, still only one time. All the way down, only one time. If you want to draw it out, if that helps you, right there, it's only touching the graph one time. Right there, it's only touching the graph one time. So, because it is only touching the graph one time or less, this is a function. Okay, now try the second example. I get my paperclip again. I go all the way across. It's only touching it one time. Still only touching it one time. Even though right here it doesn't really touch it at all, keep going, still only touches it one time or less. So again, this is a function. Only touches it one time. Okay? Finally, number 3. If we did our paperclip on this example, as you can see, the vertical line touches the graph multiple times the whole way. So right here, it touches it like 4 times. That is not good. So because it touches it more than once, it is not a function. So that is Unit 1, Cycle 3. Is it a function? Notes.